This episode is a little bit different to my normal how-to format. Sometimes it's a good idea to stop just looking at how we do things and also think about why we do them. This episode is a collaboration with my good friend Chris Fryer. He's going to upload a version of it to his channel. I'm uploading a version of it to mine. But straight after this, I've got another video coming up which is all about on-off-free flashing, and then I've got one about software coming up. So there'll be a lot more technical content straight after this. But I think this is really important because it shows the real benefits that automation technology can bring to people's lives. Enjoy. Hi, I'm Jonathan Oxer.
I'm Chris.
And this is SuperHouse.
Is it?
Sure. I've known Chris and his identical twin brother Nick for about 20 years now. In fact, way back when, Chris and Nick worked for me as programmers at my software company. And for about the last year or so, I've been working with Nick and Chris on a variety of projects related to using technology to make their lives easier. Now, unfortunately, Nick passed away about 2 months ago, but I've been continuing with those projects with Chris. A lot of the time when people hear that I work on home automation systems, they say that's just toys for rich, lazy people. But when you see the difference that it can make in the life of someone who doesn't have the same physical mobility as I do, it really makes all of that sort of thing worthwhile. Yes. So what we're going to do today is look at a couple of the projects that we've been working on and not go into them in great detail. We can follow up with later videos about that, but just show some of the things that you can do using open source technology and home automation, Arduino, and all of those sorts of related things. Definitely. And see what sort of a difference it can make in people's lives. Now, a lot of the motivation for this as well is that products that are specifically designed for assistive purposes can be extremely expensive. They can be proprietary, so closed, and you really can't modify them to make them suit individual situations. So, Chris, you got, just as an example of the sort of numbers we're talking about, you got this wheelchair fairly recently. It was last year sometime. How much was this wheelchair?
Over $45,000.
Yeah, well, obviously there's a lot of engineering in a wheelchair, but $45,000. I mean, you can buy a really nice car for $45,000. So things that are required just for general day-to-day life can be really expensive. By doing everything in an open way, it means that things can be customized. It's not just buy a device and then use it as it was originally designed. With open source, of course, you can remix, you can modify, and you can make things really suit an individual needs. So one of the projects that Nick and Chris worked on over quite a number of years is a little thing called a Buttonbox, which has got switches that they can press that then send keystrokes to the computer, and that can be used for things like gaming or controlling software like Fusion 360. So what sort of things do you use that for?
Play games.
Mm-hmm.
Mostly.
Yeah. Cool. And
but it's most useful with CAD software.
yeah.
Such as Fusion 360, Blender. I'm also a pretty quick typist at it. The Buttonbox helps with that.
Mm-hmm.
Yeah, I'd be screwed without it.
Yeah.
So to speak.
Yeah, and the Buttonbox is a really good example of a sort of device that needs to be customized to suit the individual, because the individual buttons need to be tuned in terms of how much force is required to activate them and the physical position of the user's hand. Now, it's not possible to make a single device that is going to suit everybody's hand and everybody's mobility. So by doing this in an open way, it means that people can tune it to suit themselves. This is connected through to an Arduino Leonardo, which is in this box. The Leonardo can then emulate a keyboard or a game controller, so that by using these switches, Chris can send either individual key presses, or they could be even strings of characters, basically whatever you want to program into it. And this is designed to just sit over the edge of the tray of the wheelchair. And because people have different size hands and different strength in their hands, this part of it needs to be customized to suit the individual. So you can see the pads here adjust the height. Now, this particular Buttonbox is really old. This was made quite a few years ago, and it was a prototype that was built. But Chris liked this one so much that he's just kept using it, and you can see that it's been modified. It's had extensions glued on here, so the original length of the little switch just came up to here, and then it's been brought out and padded up. And just recently we modified it by cutting out the edge of this mounting base here, and Peter attached this little switch so that that can work on the thumb. Originally it just had 4 switches here for fingers, but now it's got a thumb switch as well.
My brother Nick, he was a huge fan of car games, like Need for Speed and iRacing. But to be competitive, he needed proportional control for the steering and acceleration. And we worked out he could use the mouse for steering, but he still had difficulty accelerating smoothly.
Yeah, because when you map one of these to, say, throttle and brake, it's just on and off control. There's no proportional output. So one of the things that we've just been looking at, and we haven't actually done this yet, is using these tiny little strain gauges. And what we're thinking of doing is making an updated version of the Buttonbox, which instead of having these micro switches, which is just on and off, we're going to mount these little strain gauges, and that will allow proportional control, which will be really useful for things like racing games. But it could also be useful for other things as well. There are a lot of times when you don't want to just have on-off control of a computer. You want to be able to control something proportionally. Because this particular Buttonbox was custom made, it's very laborious, both in terms of making the physical structure of the inputs, but also the controller. At the moment, this is an Arduino Leonardo with a whole lot of hand-wired connections inside this box. So to make that easier, I designed this little shield, which basically just provides a breakout for some of the I/O and ground and power. So what you can do is take something like an Arduino Leonardo, plug this shield into it, and then that provides an input for a device like this. So it saves a lot of the messing around with wiring and lets you focus on just the mechanical part of the controller itself. But I've also been working on another little device. Now, you've probably heard of the Xbox Adaptive Controller from Microsoft. This is a controller that provides a number of large, easy-to-use inputs. but it also has a row of 3.5mm sockets on the back. So the idea is that you can build your own custom game controller by using whatever buttons you want, or it might be things like foot controls, or it might be like a SIP controller, or it could be chin control. It doesn't really matter. As long as you've got something that can provide switched outputs, you plug it into the adaptive controller, plug this into your game system or computer, and then you can trigger all of the normal actions that you would on a game controller. So as far as the console is concerned, you've just plugged in a normal controller. So what we wanted to do was something similar to that, but open source, smaller and cheaper. So we've just been working on this, which is the mini open adaptive controller. It's a lot smaller than the Xbox adaptive controller because it doesn't incorporate the controls on it directly. What it provides is a series of 8 inputs in a similar sort of way, 3.5mm mono sockets. So you can just plug in switches or buttons or touch switches or whatever you want to use. It's got USB-C on it, and it has an ATmega 32U4, which is the same as the Arduino Leonardo. So the idea is that with this, you can plug it into your computer, plug in whatever input devices you like, and build your own custom controller. There's also going to be a little OLED on here so that we can do things like have different modes. So what Chris does at the moment is, on the Leonardo, which is running in here, it's running a program which reads from these switches and then sends different events to the computer depending on what mode it's in. For example, there is a mode for playing certain games. There is a mode for Fusion 360 that sends commands that are relevant to that. And the sketch has to be updated on here in order to change the mode. So what we want to do is streamline that process and make it really easy to define your own custom modes and specify what you want the key events to be, and then be able to switch between modes very easily.
These are touch switches. They make it easy for me to control my wheelchair. For example, this button, switch modes, so I can do things like this, or turn this switch, turn the back, that allows me to turn pages, click, other stuff like that, take photos, play games, whatever. It's extremely useful, and without it, I wouldn't be able to use my phone. So it's a huge thing for me. But there's a few issues.
These particular touch switches are powered from little coin cell batteries, and that makes it very convenient for installation because they're self-contained. You just plug the output into the wheelchair and it all works. The big problem is that the batteries in them only last about a month, and if you've got a couple of them on your chair, it means that you're constantly replacing batteries. And even worse than that, replacing the batteries isn't easy. It's not like a little case where you can clip open a cover, slide a battery out and slide another one in. The case is actually screwed closed. So if Chris is out somewhere, he might be away from home or going to the movies or something, and the battery at that particular point goes flat, then whoever is with him has to use a screwdriver to take the case apart to replace the battery, which they probably don't even have with them.
Yes.
So it's really inconvenient. And when that happens, Chris no longer has control over some of the functions of his wheelchair. One of the other big problems is that the cost of these things is just so high. These little touch switches have only got a few dollars worth of parts in them. But to buy one touch switch for this particular wheelchair is almost $500 US. So by the time you add a couple of touch switches, that's a really prohibitive cost for most people.
So we decided to do something about that.
Yeah.
So we started designing our own open source touch switch.
Chris's original idea was that because changing the batteries was so annoying, he really wanted a version that was similar to the existing design, but it just had a really high capacity battery in it, so that if you're changing the battery maybe every year or so, it would be far less annoying than having to do it about every month. But then we decided that since the chair has plenty of power anyway, and it's got this big battery pack, it's designed for running motors, what we can do is just take power directly from the chair. So at the moment we're working on a prototype for a version of a touch switch which is functionally equivalent to the one that is on Chris's chair right now, but it will take power from the chair, so there will never be any need to change batteries.
Then it would be a lot cheaper.
Definitely.
Hell of a lot. A few years ago, a good friend to me and Nick said we dealt. He passed away. And his father donated 2 of these tiny heaters. These heaters, what they do, you melt them on your wheelchair.
So if you've ever gone out on a really cold day and your hands have been really cold and then you've got a pen and tried to write something, you've probably had a lot of trouble moving accurately because your fingers just don't work properly. Now for someone who is driving a wheelchair, they have the exact same problem. The wheelchair control in Chris's case is a joystick which requires very fine motor movement in order to control it accurately. So Nick and Chris would have lots of difficulty going out on a cold day. When their hands get cold, they couldn't control the wheelchair properly anymore. So the little hand heaters help relieve that problem. By mounting them on the chair just near their hand, it blows warm air over their hand and then allows them to keep control of the wheelchair. The little hand heaters that they were given a couple of years ago aren't available anymore in Australia. I think they used to be, and you can still buy them in some places overseas. But we really wanted to be able to make them available for people who could benefit from them. So what we did was design these little hand heaters. This steel case was all, was it laser cut or water cut? Laser cut. So Nick designed the physical case for this. It was all laser cut and then bent. So it's in a nice solid container. And these are designed to mount either on the chair permanently, and Chris has one mounted just down near his right hand, or they can be put on common mounts like a GoPro mount and then put in a convenient place. So what Chris often does is have these sitting on his desk when he's using the computer. They can be blowing onto his hands so that he maintains dexterity and doesn't get cold hands. So I think these have made a really big difference in your comfort and ability to get around.
That we wanted to give other people that ability as well. Like every wheelchair should, except for these. But they're difficult to get. And more like impossible
Yep.
to get, and they're expensive.
Like pretty much all assistive technology, as we've discovered, it all seems to be ridiculously overpriced. So we want to be able to do something about that. Just down here you can see the hand heater. It's mounted to the frame of the wheelchair down on this little adjustable arm, and it's set up so that it blows directly on Chris's hand when it's sitting over the joystick, and that way his hand stays nice and warm. The heater itself gets power from the chair. There's a plug in the back here and a cable that goes in through the chair, and then just along the side here is a control panel, and this can be used to turn the heater on or off and adjust its heat level as well. It has multiple modes, so it can blow at different strengths and generate different amounts of heat. Chris controls his wheelchair using a little joystick which is mounted down here on the frame. It's a special type of joystick which requires very low force to activate because it has Hall effect sensors and a magnet. What that means is that he can move the joystick full deflection with very small force. It's also extremely accurate, so it only moves a few millimeters to get full scale from on any particular axis. And what we wanted to be able to do was use the output from this joystick to control other things. So what we figured is that because Chris can't activate a normal joystick, like on a remote control transmitter, if we could use the signal from this joystick and substitute it into whatever device we want to control, it would allow Chris to take control of it.
What about favorite hobbies? Before we got to wake up, was to fly, radio, control planes, and drive RC cars. Nick was quite good at both, but sadly we lost the ability. But now we've been working on a device that will hopefully give me back the ability to fly. I'm a Fusion 360 nerd. Last year I couldn't help designing this aircraft. Now, this one flies amazingly, but I would like the ability to fly it myself.
This is Nick's old wheelchair, which we're using at the moment for prototyping on this control system. Normally the signal from the joystick on the chair comes up this cable and it runs into the chair's controller. So that's how it gets the direction and acceleration signal. So what we've done is disconnected the joystick and run the cable through onto a board connected here. There is an Arduino Mega inside this box, and what it's doing is reading the signal that comes from the joystick. Now that in itself sounds pretty easy, but it turned out to be trickier than we thought because the output that comes from this joystick is not, it looks like a serial connection, but it's not. And it's an analog signal that varies around a central reference voltage, and the reference voltage is derived from the chair's controller voltage. So what we needed to do was come up with a circuit that would read the reference voltage and then read the X and Y axes that are coming through the connector, and then figure out what the offsets are relative to each other. And that's all done on a little circuit board which is inside this box. So the Arduino can then use that to figure out the X and Y deflection of the joystick by reading those 3 analog values. With this system, this is an early prototype. We've got it functioning, but it's cobbled together. There's a lot of hand wiring in it, and it's not very neat. But then what we can do is, once the Arduino can read the joystick from the chair, we can redirect that to some other system. And what we have here is an output that goes from the Arduino into a modified FlySky remote control transmitter. So physically inside the case is a little RC network, and what we're doing is sending PWM values down this cable. They're being filtered inside the box by the RC network, and then that signal is being sent to the transmitter in place of the regular joysticks. And this switch allows us to change modes. So with the switch in, the transmitter operates as normal. You can control it just using these joysticks. By flicking the switch out, it accepts its stick position coming from the joystick attached to the chair. Now in this case we've only got one joystick, but we can actually handle dual inputs, so that if, for example, you wanted to fly a drone, then you need 3 axes. So the 2 joysticks allow you to do that. We can have one joystick on one side of the chair and one joystick on the other. The way this is set up right now is fine for doing things like flying a glider, because you only need 2 axes, and it also works pretty well for controlling things like a combat robot.
Hello, I've been working on this system for a while, with John, and basically it takes the analog output from the wheelchair joystick. It allows you to switch it so you can plug in like a game controller, or you can use it to fly radio controlled devices, like drones or planes or cars, but there's all sorts of other more useful functions that it could do, like perhaps driving an actual car.
With this early version we have analog signals coming out of the Arduino here going into the transmitter, but what we want to do is totally change the architecture. So we've been working on an updated version. This is a little board which will be added into the back of the transmitter. It's got a CAN bus interface on it. So what this will effectively do is add CAN to the FlySky transmitter. And there will be a CAN connector on here in place of this connector, and then we'll be able to plug into it and send commands to the transmitter, which will basically dictate the stick positions. So we're just working on that. I've just received the PCBs for this and put the parts on, started populating it, but I haven't got all of this powered up and working yet. And this is a replacement for this box, which brings the input in from the joystick on the wheelchair, and it sends the output. So instead of sending an analog output, what this one does is take the input from the chair, and it has pass-through. So what we can do is put this in series with the chair control system and then switch modes from here, so you can have this permanently attached to the chair instead of having to attach it and disconnect it. This can be permanently connected, and when you want to use the chair, have the switch in one position. When you want to send the signal somewhere else, flick the switch. And it's got a couple of connectors on here for CAN bus. And the idea is that what we can do is use the joystick from the wheelchair to control the chair, but also to send messages over CAN bus, which can then be used for controlling other devices. So by combining these two systems, what we can do is take the chair joystick input here, send it onto the chair control system, have CAN bus coming out of here, and send that to the FlySky transmitter. And what that means is that we can use different input devices. This particular one is set up for the joystick from the chair, but we could also do devices like a Buttonbox, which sends CAN events, and we could do foot controls and like sip and puff controls for people that need different types of input devices. We're going to do more videos in the future showing more detail about some of these projects. So if you want to stay up to date with that, make sure you subscribe. I'm going to put links in the video description both to the SuperHouse channel and to Chris's channel. So if you want to learn about Fusion 360 and see some of the cool things he does, make sure you subscribe to Chris's channel. And if you can support our work on Patreon, that would be fantastic as well. It'll help us to keep working on these devices and make them available for more people. So thank you very much, and go and build something cool.
See ya.